Hi everyone, welcome to the series 1000 Must Solve Problems for NEET Physics, Part 3. A particle moves for 8 seconds. It first accelerates from rest, then retards to rest. If the retardation is 3 times the acceleration, then the time for which it accelerates means we have to find time of acceleration. So we know that acceleration divided by retardation is equal to time of retardation divided by time of acceleration. So what is given? Retardation is 3 times the acceleration. So alpha divided by 3 alpha is equal to, beta means 3 alpha is equal to, and one more point I have is total time for which the particle moves is 8 seconds. So therefore I can write time of retardation plus time of acceleration is equal to 8 seconds, or time of retardation is equal to 8 minus time of acceleration. That I'll substitute here. In the place of time of retardation, I write 8 minus Ta divided by Ta. So here alpha and alpha gets cancelled. So this implies 1 by 3 is equal to 8 minus Ta divided by Ta. Let me simplify a little bit. This implies Ta is equal to, time of acceleration is equal to 3 into 8, 24 minus 3 Ta, or this will be equal to 4 Ta equal to 24, or Ta equal to 24 by 4 is equal to 6 seconds. Therefore time of acceleration is equal to 6 seconds. Fourth option is the correct one. Then we will move on to the next question. Question number 22. A car starts from rest and moves with constant acceleration. The ratio of distance covered in nth second to the distance covered in n seconds is, distance covered in n second is given by x is equal to u t plus half a t square. Okay, but the thing is the car is starting from rest, so u is equal to 0. Okay, so distance traveled in n seconds will be equal to half a n square. This is equation number 1. Distance traveled in nth second is equal to u plus a by 2 into 2n minus 1. So u is equal to 0. Therefore distance traveled in nth second is equal to a by 2 into 2n minus 1. So what we are asked to find out? We are asked to find out ratio of distance traveled in nth second to the distance covered in n second. So Sn divided by Xn we have to find out. So Sn is a by 2 into 2n minus 1 divided by Xn is a by 2 into n square. See, a by 2 into n square. So a by 2 gets cancelled. 2n by n square will be equal to 2 by n, okay, minus 1 by n square. 2 by n minus 1 by n square. So third option is the correct one. Next we will go to question number 23. A stone falls from the top of the tower in 8 seconds. How much time will it take to cover first quarter of the distance starting from the top? So let us suppose that so here there is a tower. Okay, this is the tower. Stone falls from the top of the tower in 8 seconds. Okay, so to travel a distance equal to h, okay, h, say the stone takes 8 seconds. 8 seconds are required. How much time will it take to cover first quarter of the distance? First quarter means what is the time required to cover first quarter of the distance? H by 4. So we know that since the stall is falling, we know that h is equal to half gt square. H is equal to half gt square. So we can say that h is proportional to t square, or I can write t is proportional to root h. So what I can do, I can write t prime by t is equal to square root of h prime by h. So this is equal to t prime is equal to t into, what is t? 8 into h prime. H prime is h by 4 divided by h. Okay, so that is h gets cancelled. So that is equal to square root of 1 by 4 is 1 by 2. So 8 by 2. So t prime is equal to 4 seconds. So therefore, first option is the correct one. Then we will move on to question number 24. A train starts from rest. And acquires a speed v. This is the maximum speed with uniform acceleration alpha. Then it comes to stop with uniform retardation beta. Okay, it comes to rest. What will be the average velocity of the train? So this I have explained in the concept. The corresponding link I'll be giving in the description. So how can we draw the corresponding graph here? Okay, we'll draw a VT graph. Okay, so train starts from rest, acquires some speed v. Okay, so this is the maximum speed v. Okay. And then retards to rest. Okay, so acceleration will be alpha, retardation will be equal to beta. Now this area, we have to find out average velocity. Correct? Now average velocity is equal to distance by time, total distance by time taken. Okay. What is the distance? Area under VT curve is distance. Area under the VT curve is distance. Means we have to find out this area. So this area, okay, is exactly half of this area. Mathematically we can prove it. Exactly half of this area. So you can try to understand. See this. So this area is equal to this area. This area is equal to this area. So half of the area of this rectangle is equal to area of this triangle. Okay, so therefore half into what is distance traveled equal to area under this VT curve, half into area of the triangle base. Okay, say this time is t, base into height means how much? Maximum speed v. Okay. So divided by t. So what happens? This t and t gets cancelled. Okay, so we get v by 2. So therefore average speed is v by 2. Next we will go to question number 25. A rocket is fired vertically from the ground. Okay, it moves upwards with a constant acceleration of 10 meter per second square for 30 seconds, after which fuel is consumed. Okay, fuel tank is empty. After what time from the instant of firing the rocket will attain the maximum height? After what time? Okay, at what time the rocket is at maximum height? So we have to calculate time of maximum height. So for which what we should remember is the particle will be at maximum height. The particle will be at maximum height. Okay. When its velocity becomes 0. When the velocity of the particle is 0, if the particle is going vertically upwards, if its velocity becomes equal to 0 means it is at maximum height. So we have to find out when its velocity becomes equal to 0. That we have to find out. So initially the rocket was fired vertically upwards. Okay. it accelerates with an acceleration 10 meter per second square for 30 seconds. Okay, so what will be the velocity at the end of 30 seconds? We will calculate. Okay, it accelerates for 30 seconds. So part number 1, v is equal to u plus at. Okay, fired vertically upwards means initial velocity is 0. V is equal to at. It is fired with an acceleration 10 meter per second square into time for which it accelerates is 30. So v will be equal to 300 meter per second, means at the end of 30 seconds, say here I'll write, at the end of 30 seconds, rocket will be here. Okay, rocket will be here, and it will be having a speed equal to 300 meter per second. It will be having a speed equal to 300 meter per second. Now, when it will reach the maximum height, it will be at maximum height if its velocity becomes 0. Its velocity has to become 0. When its velocity becomes 0, we will calculate. Okay, so for that we will use v equal to u plus at equation. Now for the second process, initial velocity is 300. Okay, for this is first process, this is second process. The rocket goes up just like a stone which is thrown upwards with the initial velocity of 300 meter per second. Now for this process, initial velocity is 300 meter per second. So at, v is equal to u plus at here, at. Okay, so that is equal to u is 300 plus what is a? Now a is minus 10. Why minus 10? Because fuel is consumed. Now rocket is not going up because of the engine. It is going up because of its speed attained. So it has a speed now 300 meter per second, due to which it is going up with a reducing speed. So it is exactly moving under gravity. Therefore acceleration due to gravity I should consider minus 10 into t. So when it reaches the maximum height, velocity will be equal to 0. So 0 equal to 300 minus 10t. Okay, so I'll write here properly, 0 equal to 300 minus 10t. So implies 10t equal to 300. So t is equal to 30 seconds. Okay, now what happened? 30 seconds, for 30 seconds, the rocket is accelerating upwards. So here I'll write 0 second. This is 30 seconds. Before its velocity becomes 0, it goes up for another 30 seconds. Another 30 seconds. Okay, now here then what is the time here? Time here is 60 seconds. Okay. After what time from the instant of firing the rocket will attain the maximum height? So instant of firing is 0 seconds. So here you have 30 seconds. Here you have 60 seconds. At 60 seconds, therefore the rocket is at maximum height. 25 is the correct one. Sorry, fourth option is the correct one. Next we will go to question number 26. A car accelerates from rest at constant rate for the first 10 seconds and covers a distance x. It covers a distance y in the next 10 seconds at same acceleration. So which of the following is true? We know that from Galileo's law of odd numbers. From Galileo's law of odd numbers, we already know that if the acceleration is constant, okay, ratio of distances traveled in successive equal time intervals. Okay, so S1 is to S2 is to S3, okay, is in the ratio 1 is to 2 is to 3. Sorry, 1 is to 3 is to 5. Galileo's law of odd numbers, 1 is to 3 is to 5. So if the distance traveled in first 10 seconds is x, distance traveled in next 10 seconds will be 3x. Okay, so then y should be equal to 3x. So directly we can go for option number 2, or else we can solve mathematically also. Okay, since the car starts from rest, okay, what we'll do, x is equal to half a t square. X is equal to half into, u is not there, a into t square. T square is how much? 10 square. 10 square is 100. So x equal to 50a we will get. Okay. Then what is y? Y is the distance traveled in next 10 seconds. So what is the distance traveled in first 20 seconds? It is x plus y, because x is the distance traveled in first 10 seconds, y is the distance traveled in next 10 seconds. So x plus y is the distance traveled in first 20 seconds. So what we will write? Half into a into 20 square. 20 square is how much? 400. 400 by 2 is 200a. 200a. So x plus y is 200a. Then what is y? Y is equal to 200a minus x. Correct now? This x will go here. Okay. 200a minus x. X is how much? 50a. 200a minus 50a. So that is equal to 150a. Now I can write this 150a as 50a into 3. Correct now? I can write this 150a as 50a into 3. Okay. So y is equal to 3 into, what is 50a? 50a means x. So therefore y is equal to 3x. Second option is the correct one. So this is the concept based explanation. This is how you can solve it actually in the examination, even if you forget this concept of Galileo's law of odd numbers. Now we will move on to the next question. Question number 27. A person throws balls into the air one after the other at an interval of 1 second. Okay, for every 1 second he is throwing one ball. The next ball is thrown when the velocity of the ball thrown earlier is 0. Okay, 1 point what they have given is a person is throwing ball upwards at an interval of 1 second. Means, say the first ball is here. Okay, he throws the second ball, okay, after an interval of 1 second. Okay, after 1 second he throws the second ball. And one more hint what they have given is the next ball is thrown when the velocity of the ball thrown earlier is 0. Means second ball is thrown when its velocity is 0. Okay, its velocity is 0 means it is at the maximum height. Okay, to what height the ball rise? When you throw the second ball, first ball is at the maximum height. Means time for which the ball was going up is 1 second. So how to calculate that maximum height? You can use v square. Can we use? Yeah, v square. Okay, I cannot use that maximum height. I can use v square equal to, it is 5 meter. Actually it is 5 meter because distance traveled in first second is 5 meter itself. Okay, yeah, I can use x is equal to ut plus half a t square. Correct now? X is equal to ut plus half a t square. Half a t square. By substituting for v, what I'll do, I'll see from the equation v is equal to u plus at. I can write an equation for u. U will be equal to v minus at. U will be equal to v minus at. So if you substitute this v minus at to the place of u here, then I'll get the equation x is equal to vt minus half a t square I'll get. Okay, so here in this situation final velocity is equal to 0. If the final velocity is 0, x will be equal to, distance traveled will be equal to minus half into acceleration is minus 10 into t square. T square is 1 square. 1 square is 1 itself. So minus of minus will be plus. 10 by 2 is 5 meter. Okay, 5 meter. If it goes upwards only for 1 second, means definitely the distance traveled is 5 meters. If it travels for 2 seconds, distance traveled will be 20. We know it, 5, 20, 45, 80, right? But if at all you have to use the formula, means you can use this formula, x is equal to vt minus half a t square. Now why I have used this formula is because, see, when you know initial velocity, okay, you have to use x is equal to ut plus half a t square. Okay. Now in this situation we don't know initial velocity, but we know the final velocity because the particle is at maximum height. So then I can use the equation x is equal to vt minus half at square. So this equation will be very handy, please remember. Next we will go to question number 27. A stone falls from rest. The total distance covered by it in last second of its motion, total distance covered by it in the last second of its motion is equal to the distance covered in the first 3 seconds of motion. Okay, the stone is falling from rest. Okay, so therefore u is 0. So distance covered in first 3 seconds, x3 is equal to half at square, half gt square. Okay, half gt square, I can write 5t square, correct now. So x3 will be equal to half at square. A is minus 10. Since the ball is coming down, it is also minus. T square means 3 square. Okay, so 10 by 2 is 5. 5 into 3 square. 3 square is 9. Okay, 5 into 9 is 45. Okay, that is 45. Distance traveled in first 3 seconds is 45. So that is equal to distance covered by it in the last second. Okay, what is that last second? We don't know. So we will use Sn formula. Sn is equal to u plus a by 2 into 2n minus 1. Okay, 2n minus 1. So u is 0. So Sn is equal to a by 2 is 10 by 2 is 5. 5 into 2n minus 1. So this is the distance traveled in last second. That should be equal to distance traveled in first 3 seconds. So what we will do? We will equate Sn and x3. So what we will get? 5 into 2n minus 1 is equal to 45. So 5 goes 9 times. Okay, so 2n is equal to 10. So n is equal to 5 seconds. N is equal to 5 seconds is the correct answer. Next we will go to question number 29. So it is a very similar to question number 28. A stone falls from rest. Total distance covered by it in last second is equal to total distance covered in the first 3 seconds. Total distance covered in first 3 seconds. So what is the height from which? Okay, so then what is that last second for how much time it is traveling? We know that we have just calculated that. Okay, how long does the stone remain in air? So we have already calculated that it is n seconds. So ball will be remaining in air for 5 seconds, correct now? So in 5 seconds, what is the distance traveled by the stone? Okay, because the stone the stone is reaching the ground, okay, in 5 seconds. So what is the distance traveled? So we know that x is equal to ut plus half t square, u is 0, correct now. X is equal to 5t square. Directly we can calculate. So 5 into t square. T square means 5 square. 5 square is 25. 25 into 5 is 125 meters. So third option is the correct one. Question number 29, third option. We'll go to question number 30. The velocity time graph of a moving object is given in the figure. Okay, VT graph is there. So whenever you see VT graph, we should remember area under VT graph is displacement. Find the maximum acceleration of the body. Okay, acceleration. So we know that slope of VT graph is acceleration. Acceleration is maximum when the slope is maximum. Okay, where is the maximum slope? Slope of BC is maximum. You see, so here you have a lesser slope. Here you have 0 slope. Okay, when you compare it to CD and BC, so this line has the maximum slope, correct now? So slope of BC is maximum. So find the slope of BC. So that will be maximum acceleration. I'll do it. So slope of maximum acceleration equal to slope of BC. So this distance, what is that? 80. Okay, correct now? 80 minus 20. Okay, divided by 40 minus 30. Okay, 80 minus 20 divided by, oh sorry, I just erase it. Okay, once again. Okay, uh, 80 minus 20 divided by 40 minus 30. 40 minus 30. 80 minus 20 is 60. Okay, so 60 divided by 10 will be equal to 6 meter per second square. Okay, so acceleration is 6 meter per second square. So definitely first option should be correct, because in no other options acceleration is 6 meter per second square. Then we will continue. The distance traveled by the body in the interval of time in which acceleration exists. Okay, so when the acceleration is maximum, what is the distance traveled? So for which I should use, I have to calculate area under VT curve gives displacement. So this displacement I should calculate. Okay, so this is area of trapezium, correct? Area of, so you have to calculate the area of this triangle plus you calculate area of this rectangle. Okay, so you can do that, or we can also use the equation v square equal to u square plus 2ax to find x. What is the formula? X is equal to v square minus u square divided by 2a. Since we have already found the acceleration, we can calculate here that x is equal to v square. So what is final velocity is 80. Okay, so initial velocity is 20. Okay, v square minus u square means 80 square minus 20 square. 80 square is 6400 minus 20 square is 400 divided by 2 into acceleration is 6. So 6400 minus 400 will be 6000 divided by 12. Okay, so we know that 12 goes 5 times, so x is equal to 500 meters. So the distance traveled during the maximum acceleration is 500 meters. Again we got 500 meter. You can also calculate area of this triangle, okay, plus area of the rectangle, or straight away you can use area of trapezium formula. Then also you will get 500 meter as the answer. So thanks for watching. Please subscribe the channel for continuous updates. So this is the part 3 of the series. So I'll be uploading total 100 videos. So if you learn all of the problems given in all the 100 videos, so you will be having some confidence to write NEET exam. Thank you very much.